we get the margin of error, don't we? We get the margin of error, and so let's say the margin of error, for argument's sake, was 0.07. I've some statistic which is, let's say, 35%, and I say 35% of the lads in CBC like rugby or something like that, or like Gaelic, right? Then what I say is we do what's called a confidence interval. What's the confidence interval again? Takes 0.07 away from, so it'll be 0.28 less than P less than, anybody? 0.42. Now, do you know what that means? When we do this technique using 1 over the square root of n, which is the number of people who took the survey, what happens is we are 95% certain that if I do this survey again, if I survey another 200 people, we are 95% confident, one second, we're 90% confident that on 95 out of 100 cases, the proportion will be in this interval. You get what I'm saying? If I interviewed 200 people, and I said, well, 200 people is, when I interviewed 200 people, the statistic is anywhere between 28 and 42%. Every single time I interviewed 200 people, 95% of the time, the result will be somewhere in this margin. Imagine I interviewed 200 people and the answer was 0.35. Imagine I interviewed another 200 people and the answer was 0.29. That's okay, isn't it? Because it's in between it's in the interval, isn't it? All right. Now to put this into context, we'll do question 8 really quickly. How many students did you interview? 80. So 1 over the square root of 80. What do you get for that? Huh? I think it was, we were finishing off in class. So 1 divided by root 80, anybody? What was it? 0.11. So 11% error. Would you be cool with that? 11% error? Right. 36 out of 80 students were in favor of the change. So 36 divided by 80? 45%. 45%, all right? Now, what I'm arguing here is that we're asked for the confidence interval. So the confidence interval is going to be 45, take away 11 is less than, P less than 56. Now, here's the deal. If I interview another 80 students, yeah, I am 95% certain that their answer will be somewhere between 0.34 and 0.56. Do you get what I'm saying? I won't get exactly the same answer, will I? More than likely. So what I'm trying to say is that I interviewed 80 students. 45% of them were in favour of the change. I'll interview another 80 students. I probably won't get 45% again, but I am 95% certain that I'll get an answer somewhere between 0.34 and 0.56. That's what we're saying. Yeah. Okay? That's why it's called the 95% confidence interval. Okay? Next one, 9. I gave you 9 last night, did I? Alright. What's the sample size, lads? 200. Okay. What's the margin of error? 0.07. No bother. Which is 1 over the square root of 200. What's the sample proportion? 84 over 200, which is 42, yeah. And finally, the answer is, I actually think they're quite handy at the moment, are they? 0.35 and add it on. It's not even 0.07. Yeah, but you're adding on 0.42. 0.07 means 7%. So you're in between 35% and 49. You could write it like that if you want. I always write it in decimals, so decimals are the way forward. Okay? So if it's 2 zeros and then 7, 7%. Oh, sorry, 0.7 of a percent. That's what you're thinking, is it? Yeah. Alright, can I move on? Alright, the next questions are a bit trickier. They're asking you about how many, they're asking you to calculate the n value, aren't they? So, I'll just keep going, guys, alright, that's alright. Alright, we're good. Alright, let's have a look at 10. Write out these as, each of these is decimal, right? First years will do this for me, no bother. So you guys are no different. We hope. We're not going to play Are You Smarter Than a First Year in this case because I don't want to know the answer. Okay? Now, that's everybody happy with that?
Yeah.
Whatever it is, if you need to use the calculator, whatever it is, just divide it by 100. Just divide the percentage by 100, and you get the decimal. Right, that's 10 done. Now, 11. What sample size is required to have a margin of 6%? So here's what you do. 1 over root n equals 0.0. Square both sides. Can anybody tell me what happens when you square a fraction? You square the top and you square the. So what happens when you square 2 over 3? 4 over 9. Perfect. So what happens here? It's going to be 1 over root n multiplied by 1 over root n. What's root n by root n? Just n. Square root of anything multiplied by the square root of the same thing is always just get rid of the square root. What's root 5 by root 5? 5. What's root Kenny by root Kenny? Or root Ken by root Ken? Root Ken by root Ken is Ken. Do you get what I'm saying? Doesn't matter what's in there. 2 square roots will always cancel each other out when you're multiplying. So, I didn't square the other side, did I? The other side is 0.06 squared. And how do I get n on its own? I could do a trick. There is a trick here. There's 2 tricks. If 2 over 3 equals 4 over 6, what happens if I turn both fractions upside down? Peter, what happens if I turn both fractions upside down? Plus 3 over 2 equals 6 over 4. Anybody suggest what I could do here as a really quick shortcut? I could do n over 1 equals 1 over. Yeah, that's quicker and better. Our n value will be, let's find out, 1 divided by 0.06 squared. Our n value is 278 people. Rounded up, 278 people required for that. Everybody cool? Now, you guys are going to have to try one out yourselves. Alright, I want us to try a 12% margin of error, and then we'll try 2.5%. So I'll start you off on line 1. 1 over root n equals what? 0.12. Off you go. What you do? Square both sides, and you get 1 over root n by 1 over root n. Yeah, 1 over n, and that one is? Did you multiply that out? Yes. What you get? Oh yeah, what you get as a fraction though? 0.12 by 0.12. Huh? I got 9 over 625. Is that right? Yeah. Or in decimals, I got 0.0144. Yeah, it is. Yeah. That's okay, Paul. Now, lads, same deal. Now, I want you to turn it upside down. How do you turn it upside down? You can do n equals 625 over 9 if you want. That'll be if you use fractions. If you didn't use fractions, you'd have n equals 1 divided by 0.0144, and then 1 divided by answer. Did anybody get 69.4 people? Alright. And to guarantee that you have it, if you only use 69 people, you'll be short. Lads, if we use 69 people, we'll be short of 12%. So I'm going to round that up to 70 to guarantee that I have just below the 12% error. Does that make sense? As in, 69 people won't be enough. 70 people will. It's discrete data. I can't interview 0.4 per person. I can either interview 69 or 70. Okay? Now, you guys do the next one, 2.5. Streamlined this stage. What you guys are saying is number of people equals 1 divided by margin of error squared. You're entitled to write that down in your log tables and learn it off by heart for your leaving cert. I don't mind. Whatever you want. Okay? Because the 1 over root n, you're going to struggle to find that in the papers as well, so you might as well just learn that off if that's the case. So, what you're going to get here, guys, is in this case, it's going to be 1 divided by 0.025 squared. That's a very small margin of error, so I'd imagine that it'd be, what'd you say? Thanks, Daniel. What Daniel said there is that if I square that underneath, oh, sorry, just square the bottom, isn't it, guys? You lads only square the bottom, don't you? Doesn't matter, but it'll still be the same answer in this case, but you guys want me to square the bottom only. And yeah, 1600, no bother. Is that alright? Alright, finally, 13, which is the last one. This is very, very easy. Okay, should be able to do this in your sleep by now. Max, first thing, what's the sample size? Great. What's the margin of error? 1 over the square root of? How many people? Thousands. So 1 over root of thousands is 0.032. So 0.032 you want, or 3.2% error. Is that alright? Peter, what's the sample proportion in this one? 360 divided by 1000, which is 0.36. And finally, what is the interval then? So you do 0.36 take away. What's it? 0.032, and you get 0.328 if you round it off to two. If you round it off to an extra decimal, and then when you add it on, we're going to get 0.392. Anywhere between 32.8% and what's the other thing? 39.2%. All right, that's me done.